We are represented globally here for this week's Embedded Executive Podcast. I'm Rich Nass. I'm the Executive Vice President of Open Systems Media. I lead the Embedded Computing Design Team, where we talk about everything related to embedded computing and especially artificial intelligence, machine learning, and all that good stuff. And that's the direction we're going to go today. My two guests are Mohammed Dogar. Mohammed is the Vice President of Embedded Processing at Renesas Electronics, and he leads everything with respect to AI at Renesas. And I'll probably call him Mo because we know each other pretty well. This is not our first or even second podcast, I don't think. And our second guest is Sakya Dasgupta. He is the founder and CEO at EdgeCortix. How you doing, gentlemen?
Very Hi, good. Rich. How are you, Rich?
I'm doing great. It's, as I said, it's morning for me. I am only one cup of coffee in, so you have to bear with me a little bit. Okay, so let me let you guys each introduce yourselves properly because I certainly didn't do it justice. Mo, go ahead.
Sure. Yes. Thanks for having us on the show. So it's Mohammed Dogar. I head up the embedded processing business development as well as our AI Center of Excellence at Renesas. So great to be here.
And just very briefly, Renesas in AI.
Yeah, so exciting times. You know, there are a lot of good things happening when it comes to AI. We are trying to really make the user journey and the whole experience for our developers much easier. Remember, the lot of customers that we're dealing with are not data scientists. How do we make their life easier? So we're looking at voice, vision, real-time analytics, and making the whole developer experience easy for the customer, starting all the way from data ops to development and deployment and down at the post-deployment and MLOps stage, and working with our partners to provide a seamless solution and ultimately have our customers go to market earlier and reach their revenue streams earlier.
Awesome. Sakya?
Sure, Rich. Thanks for having me. Exciting to be on this call together with Renesas, who's been a long-term strategic collaborator and partner for us. So I'm Sakya Dasgupta, founder and CEO of EdgeCortix. EdgeCortix is an early company. We are a startup founded in 2019, but scaling up quite quickly now. As I mentioned, working very closely with Renesas for several years now. Our focus is a software-first fabless semiconductor company, bringing AI solutions from software all the way to silicon. And as Mo mentioned, we are looking at enabling customers across vision all the way to generative AI applications with high power efficiency, especially in size, weight, area constrained environments which the edge pertains to. So yeah, great to be on this podcast and looking forward to have the conversation with you.
Awesome, thanks. So let's set the baseline. I believe we're revolving this around heterogeneous computing with respect to AI. What does that exactly mean, Mo? And what are we comparing that to?
Yeah, I mean, if you think about the heterogeneous architecture of computing have been on the rise for the past several years now, and it's certainly in the context of AI, where we need more compute power, there are high workloads, as Sakya mentioned, that we want to make sure they work in more constrained and more efficient way. And it's going to continue to evolve. And at Renesas, we have a lot of devices where we have not just the CPU, but also have an NPU or AI accelerator, for example, different architectures. I mean, imagine when there were multi-core systems appear, right? They were homogeneous, so the all cores were similar. But in the heterogeneous computing, the cores are fundamentally different. And they have different nodes, have different capabilities, a different way of executing instructions. So how do we handle all those challenges? And this is exactly where, what I was saying at the beginning. If you think about in the AI world, you have customers coming in, who are not data scientists. Now they have to learn all about how to implement AI, but also they are having to deal with hardware architectures, which are fundamentally more complex. So what we are trying to do at Renesas is to having a customers come in, where they have data or don't have data, and to be able to to support them in that stage, and then comes the middle part, the development part. And this is where the tools are fundamental. And that's how we partner with EdgeCortix as well. That, you're developing, whether it's for the constrained edge devices in terms of real-time analytics or some machine vision applications. You have now architectures having this different complexity. And, we partner with EdgeCortix to actually be able to support those heterogeneity in terms of architecture to be able to provide a seamless solution to our customers. So that's where really I think we're currently looking at. It's a lot of challenges in that area.
Yeah, and just pulling that thread forward a little bit. So heterogeneity, for us, as kind of Mo mentioned, really comes out of the fact that, especially in an edge environment, you have various different form factors, you have various different types of processing elements. You also have a diversity of applications, as well as within the applications, within the machine learning model landscape as well. As we have now seen, there's not only vision applications driven by traditional convolutional type models, but now we have generative AI, transformers, which are the backbones of those kind of models. There's an inherent heterogeneity across that model landscape as well. So the types of software tools and frameworks that we are building tries to abstract that complexity and the heterogeneity of the underlying hardware itself, and then provide high-level programming models and interfaces that can enable much less pain point for developers to deploy that solution in a much more easier manner, as they're accustomed to in traditional models where you have a lot more homogeneous architecture.
Okay,
Yeah.
what you were describing for me sounds like a software nightmare, and we're going to get into that in just a minute. Before we do that, I want to do one more baseline setting. You mentioned generative AI, and I want to make sure that the audience understands exactly what you're referring to there. Sakya, what are you referring to when you talk about generative AI?
Great question. So in general, traditional models have focused largely on one type of application. For example, let's say computer vision or natural language processing. The whole idea of generative AI is the ability to abstract more information and then be able to generate that, whether that's a language model. So for example, text-based models, as we have now seen with ChatGPT or others, or it's a large vision model where you have multimodal models working hand in hand together. Those are typical examples of generative AI, which typically you would not have seen in the past, where you have a single modality of application.
Yeah,
Excellent.
I mean, just to add to Sakya, I mean, think about now a robotics type of applications where you have multitude of different models play. You have the vision, you have probably some sort of a voice recognitions happening as well as different sensing elements that are controlling that appliance. So really, I think generative AI is really helping to make it more holistic across those very complex applications.
Okay, let's talk about the real challenges that a developer is facing. Sakya, you go first. What are the things that really keep the developer up at night when he's got to design a system with this technology?
Oh wow, yeah. I mean, that's a deep question. I can probably spend an afternoon and an evening just talking about that. But but in a nutshell, as we already addressed the challenge that heterogeneity brings, the first fundamental challenge is that you need to be able to balance trade-offs between performance, energy, accuracy, and reliability. Those are the fundamental tenets of deploying any solution, whether that's at the edge of the data center. And at the edge, that problem becomes even more challenging given you have this diversity of processing elements as well as applications. The second biggest challenge that we have seen with software models is portability and scalability of the softwares across the different platforms and devices. And that's also an area where historically, our work with Renesas comes in. Renesas themselves have a diversity of different types of processors, whether that's microcontrollers or microprocessors. We as a company, we have been building alongside a software, our own coprocessor or accelerator. So having a software that can manage all those diverse workloads seamlessly, preserve the user experience of not having to understand the underlying complexity of the hardware, and then be able to provide a tool chain where you're going from software development all the way to production scale deployments. Those are the fundamental challenges that we try to solve from a software standpoint.
Mo, do you want to comment on these challenges?
Yeah, absolutely. I think I'll like to touch upon, Saki covered it quite well from a performance and from a portability point of view. I like to bring up the sustainability aspects of this, right? We talked about Gen AI earlier, right? It requires, there's a lot of, overhead having those multimodal applications and vision in other areas. We got to make sure that ultimately, we are actually developing a more sustainable, more low power solution. And I think software in combined with the nice power modes in those devices is going to really help. So I think, sustainability, we cannot have this intelligence on the cost of sustainability. So I think this is where an efficient software architecture really, interconnected with the hardware is actually, applying and then producing a sustainable solution is really the way forward.
Okay, that's a good segue into where I want to go. You're making this sound real easy, Mo. Just take your software, just lay it out and move on to the next step. I got a feeling that that's not how it works. Saki, I got a feeling you're chomping at the bit here. Let's talk about the software part. Saki.
No, sure, absolutely. So, if we unroll that a little bit further, typically you're looking at various types of fundamental challenges that we are trying to unroll. Partitioning and distributing a typical application for an end customer across different processing elements is a major challenge. Let's take the example of even a microcontroller today. You might have a particular type of CPU that works hand in hand with a dedicated neural processing engine. Because of the diversity of those two elements, software needs to be able to manage the trade-offs that comes as a result of that. From a model perspective, um, Edge requires optimizing the model for that constrained environment. One of the techniques that traditionally machine learning engineers have used is called quantization, which essentially means that you take a model that was working at very high precision, let's say 32-bit floating point, in a larger environment, unconstrained environment, and you bring that at a lower precision to the edge. Now, the software not only needs to manage the diversity of the processing elements, let's say CPU and a neural processing engine, but it also needs to manage the diversity of the different types of precisions that comes from quantization. These are some fundamental challenges that we are actively solving hand in hand together with Renesas.
Yeah, and another thing I'd like to add here is now, how do we bring the two worlds together? So there is the AI domain and there is the embedded domain, right? And this is where the glue comes in, where I think our partnership with EdgeCortix really brings that glue together. Think about a typical embedded engineer sitting in his office, a bit cheesed off because his boss has asked him to do something the next 6 weeks. Now he's an embedded engineer, right? So we need to help him, on the data side in terms of, we talked about optimization, and at the beginning we mentioned about these constrained devices. How do we make sure that he understand, what data, what accuracy he needs, and then bring that into the embedded space where we have almost a separate environment developing the software project. So bringing the two worlds together, I think, is really the way forward. And that's, again, having a seamless software layer where you have this context awareness happenings at the API level, and then you actually transfer a model that you have built into a C code or another application into the space where you can actually develop an application.
And Mo, you said, one sec, Saki. Mo, you said 6 weeks. What can you legitimately do in 6 weeks?
Do you know what? It all depends. The biggest nightmare right now, having too much data. And the good thing about it is having too much data, right? So you need tools now to be able to see what exactly you want to measure. So if the upfront side, you have a good tools to really optimize what you need to receive, think about it. We recently worked with the manufacturers who develop PV inverters for solar panels, right? And they wanted to detect, it's a real problem. There's over DC arc fault that actually causes a fire, and also the aging cable. Now he wanted to have a 90% accuracy of that problem that he was trying to solve. Now if he can label the data and really be accurate, yes, he can do it. We did it actually in 6 weeks when he did the data collection, work with them, they develop a very optimized model, and then deployed and have over 90% accuracy. So having the right tools, having the right enablement, I think a lot can be done. For sure.
Okay.
Not always in 6 weeks.
Yeah, and just to add to that, so as Mo mentioned, data is a very important piece of that puzzle. If you go back to that previous discussion on generative AI, the model has a role to play as well. So when we are building these tools, if you think about generative AI, one of the biggest challenges that it solves, it's able to do things that traditional CV models, computer vision models could not. And case in point being, there are let's say a people detection application within an industrial factory floor, and you can use a convolution type models there, but it's typically a lot more data hungry. So going back to the data point that Mo made, you need a lot more training data, and it's more sensitive to post processing. So you have to do a lot of extensive post processing. And when that use case scenario at the actual deployment changes, it's not as robust. What we have seen with generative AI models, there are models which require a quarter of the actual target data to achieve similar performance. And it's also more robust in environments. Going back to that people detection, that same model that required less data is now able to provide better accuracy even in low light conditions to detect small objects. That's one example from a typical industrial use case scenario where having the right tool chain, being able to support those generative AI models, will give you a lot more value alongside the traditional computer vision models that were more data intensive. So all of these holistically needs to work together. That's the kind of software challenges that we are trying to solve together.
Excellent, excellent. So there's obviously a reason why we have both you guys on here at the same time. There's a partnership. Why don't you start, Mo? How does this partnership work?
Yeah, absolutely. Like I said, we explained the challenges that software engineers has, and you challenged me on the 6 weeks window, right? So how do we enable our customers for them to focus on what they know best, and what they know best is their application, right? And we identified, of course, with these heterogeneous architectures that's evolving, within a complete portfolio of embedded processing, where we have in MCU we have a CPU with the AI accelerator, or we have an RZ space, we have our own DRP accelerator as well. How do we make sure that different architectures, customers can seamlessly develop AI applications? So that's where we wanted to, and these are those heterogeneous architectures where has that not the same, right? They have different instructions, and how do we almost, I would say, hide some of those complexity and give the software a way forward? And that's where we came up. We have been working with Saki and his team at EdgeCortix for many years, and we have very some successful customer businesses that we want together. We want to take that partnership further to say, let's work on this together, develop a holistic customer journey, a tool chain that really takes care of all of these challenges that the new AI world brings, and provide customers a seamless solution.
Awesome. Do you see it the same way, Sakia?
No, absolutely. And as Mo mentioned, it resonates very well. When we started as a company, we were quite different in the sense that we were taking a very much a software first approach to building AI silicon, whereas historically it's been the other way around. What that meant is we wanted to create a software toolchain and framework that can embrace this heterogeneity we have been talking about, reduces the pain point for customers, and unifies a single software toolchain across different types of processing elements. We found that resonated very well for the types of challenges that Renesas was trying to solve internally. And that laid the foundation for an early collaboration for us, which has worked very well over the last few years. And we as a company, even on our own silicon roadmap side, we are solving the challenges at the upper end of the edge market with models like transformers, generative AI. With a single unified tool chain, we are now able to augment capabilities across microcontrollers, microprocessors that Renesas has, and as well as capabilities that customers might want at the upper end of the edge market with solutions that we also bring ourselves with our own coprocessor or hardware type solutions. As a result, I see this really a win-win partnership on both sides.
Yeah, great stuff, Saki. I'd like to add is, if you think about it from a customer engineer point of view now, what it means for him is that he doesn't have to worry about those complexity in the architectures, right? What he has with the software is when he's compiling his software, when he's partitioning his workloads, right? All he has to worry about, this is the performance level I need. This is the final, power consumption outcome I'm looking for. And the compiler, this is where it comes in, this, a Mara software framework that we're working with EdgeCortix on to provide that heterogeneity sort of layer seamlessly for him, right? And he does his application, he does the division in terms of how his workloads are, and actually ultimately develop a solution that is efficient in terms of performance, power, and resources.
Exactly right. So it's a developer-friendly solution that we have focused on building. The biggest challenge that we have seen in the industry is the hardware complexity. One of the first things that we had started, Rich, when we, as a company, we took on the challenge of FPGAs, field programmable gate arrays. And anybody who's worked with FPGAs in the industry knows that they are very, very difficult to program, let alone for AI. So we tried and tested our software toolchain on FPGAs, because if we could make that FPGA pain point better, then clearly for developers, they should have a seamless flow. That has been taken forward with many of the things that we are doing today with Renesas and ourselves. The idea is, as Mo mentioned, take away the pain point of the hardware complexity. Typical software developers, even in the embedded world, don't want to deal with the underlying pain point of the hardware and make the solution as machine learning framework friendly as possible.
And just to conclude on that, I think now we have an engineer all set up with the tool in front of him, right? Now we want to give him additional support in terms of application examples. So from Renesas, we have developed what we call is applications. Do a lot of pre-trained model in the vision space, also in real-time analytics space, where they have a running start on a certain type of models, or they want to work on a multi-model applications with the software example, a complete SDK, and the hardware platform to be quickly develop his application and get to market.
Okay, so I'm at day one of my 6 weeks that I got to get this thing done. Where do I start, Mo? What's my first step?
And the first thing you need to do is picking up your right hardware that you need, right? And obviously, to me, my advice to engineers is write down what are your pain points, what are the problems you're trying to solve, right? And ultimately, it comes down to the 3 or 4 areas the second I mentioned in terms of being efficient, get to market early, and have that value add for their pick that, and then they have a seamless tool chain, right? This is where the beauty of our partnership comes in. We have a seamless tool chain where we have the Renesas from the embedded side, have an excellent hardware, and the libraries to support that, together with the software, with the EdgeCortix. They have a complete framework to a kickstart and get into this speedy development and time to revenue.
You agree, Sakya? Is that the right starting point?
I would slightly differ on this one more. I would say, while I agreed with most of the things there, I think the starting point that we are enabling for customers here is start with software. You don't have to necessarily worry about the hardware. They can start with that application and things that we are doing in the model zoo landscape. They can start with the application. Don't worry of the hardware complexity. Try different tool chains, test out your application. Then, of course, ultimately you're working with the right hardware, bring it to the hardware. So then, we are synergistically meeting at the point of what the customer wants as a solution. And that's the pain point that we are taking away together with Renesas, what historically has been or plagued the industry, where you get into the complexity of the hardware.
And as you can see, right, a guy from a hardware company versus a guy from a software, right? So you can see a clear two worlds coming together.
And let's wrap with just a few words on generative AI. Mo?
Yeah, absolutely. You know what? This thing there's so much buzz out there, isn't there, about Gen AI? But I just want to put some stats in front of you. When you talk about Gen AI, you're looking at 10 times more compute versus regular queries and a lot more cloud cost, right? And also, what we want to do now is moving forward, and exactly where this partnership comes in is to how do we bring this Gen AI efficiently at the edge, right? That means having been able to make those decisions real time on the edge, where you need to think about this model size, which, typical model, you're talking about billions of parameters of model, from anywhere from 1 billion to, 100 plus. And 1 billion could easily be in 1 gigabyte, and this is where quantization and other aspects comes in, and also be able to manage the challenge of the memory bandwidth, right, as well, which is Gen AI is less compute heavy but more memory bandwidth heavy. How do we address that? So a lot of exciting things happening in terms of hardware architectures and software to be able to effectively and efficiently deploy Gen AI at the edge. Endless applications already in play, a lot more to come.
Exactly right. And just to pull that thread further, I think if I give you two keywords that Gen AI brings to the table is contextual awareness. That's what you get much better than what has been possible from traditional models because you're working in a multimodal environment. You can now lean on vision, text, language, interaction. So diverse applications at the edge across video search, defect detection, robotics and autonomous navigation now being used with generative AI, human-robot interactions. So all of these places, we are seeing a key role of generative AI with low power at the edge while preserving the efficiency that you get from edge AI or edge computing environments.
Awesome. Thanks, guys. I mean, this is about as plain as it gets. You guys are living at the edge, literally, figuratively. And I think this really lays out a good roadmap for somebody who wants to get really involved in this stuff. So that was Saket Dasgupta. He is the founder and CEO of EdgeCortix. Mohammed Dogar. He is the head of embedded processing and all things AI at Renesas Electronics. And I'm Rich Nass with Open Systems Media. Thanks, guys.
Thank you, Rich.